Hello, guys. Okay, so this is question 11, the 11th question of your big revision pack of questions, with 20 questions in total. And this is a question about Jack, who is answering a multiple choice exam. Okay, so a multiple choice exam consists of 20 questions. So we've got 20 questions, with each question containing 4 possible answers. So every question has 4 possible answers. Each question has only one correct answer. So we will have 1 correct and 3 false, right? So in this case, the first answer is correct and the other ones are false, but you have many different ways of having that, right? Jack takes the exam and for each question randomly chooses one of the 4 answers. So he's just randomly gonna pick one of the answers. Okay, A, find the expected number of questions Jack answers correctly. All right, expected number of questions. So this is interesting. So guys, here the crucial thing is to recognize a binomial distribution. We are looking at a binomial distribution. Why? Because with binomial, remember the introduction that I gave you with the crush? And that we were going to text our crush. And every day our crush could answer or deny or like ghost us. And there was a probability of answering that was 40%. And a probability of ghosting us that was 60%. So with binomial, the crucial thing is that we have 2 outcomes. And there's a success and there's a failure. And then we may be interested in the number of successes, the number of times that something happens that is seen as a success. Okay, so X is the number of successes. And I think we can say here that X, like we're going to say the outcome of success is that he answer a question correctly. That is our success in this case. And this is to answer not correctly a question. Okay, so X will be the number of successes, so that is the number of answers that are correct. So correctly. Answers correctly. Okay, so now we're looking for the expected number of questions that Jack answers correctly. So remember with a binomial, when X is binomial with a certain n and p, then the expected value, which is called like this is written like this is also on your summary sheet that I gave you. The expected value will be n times p. So basically what it does, guys, it looks at the number of trials and we multiply it by the probability of success, because again, that is what it is, right? N is the number of trials and P is probability of success. So remember that when they ask for an expected value of our X, and we have denoted X as the number of successes or the number of answers or corrected answers questions, the expected value will be n times p. Okay, so what is our n here and what is our p? Well, n is the number of trials. And in this case, like, how many questions do we have? We've got 20 questions, so that can be seen as our trials. So n will be 20, and p is the probability of success, right? So our probability of success, what is our success? That is to answer the question correctly. So that is given here, right? So P, what is P? If we have a question, there was just one that is correct and the others were false. So the probability of answering correctly is simply 1/4, isn't it? If we have 4 answers and just we're going to pick one randomly and one is correct, then the probability of answering the correct one will be 1 over 4. So the probability of success is 1 over 4. So this is 1 over 4. Okay, so the expected value of the number of correctly answered questions will be 20 times 1 over 4. So that is 5. That makes sense, right, guys? If you have 20 questions and you're going to answer them correctly, but again, every time you have a chance of 1 over 4 to answer correctly, and you've got 20 questions, how many expected questions will you answer correctly? That will be 5, right? Because you've got 20 questions in total. You just multiply by the probability that you're going to answer correctly. So this is how you compute the expected value in a binomial distribution. So this is important, guys. All right. And then B. What is B? Find the probability that Jenks answers exactly 4 questions correctly. Well, now we've done the hard work. We've done this. We've denoted X is the number of correctly answered questions. And now we know that X is binomially distributed with an N and a P. So X is this, 21 over 4, right? So X is the number of correctly answered questions. So that's B, 21 over 4. And therefore, we're looking for the probability that X is exactly 4, isn't it? The probability that Jack answers exactly 4 questions correctly. So perfect. So that's quite simple now. The calculator is going to do the work. So now is it PDF or is it CDF? Question mark, question mark. I hope you're all saying PDF now because we're looking at one specific value. CDF is when we have a range. So this is binomial PDF. And then we need 3 things. We need the N, we need the P, and the value. So again, N is 20, P is 1 over 4. Every time we answer a question, there's a chance of 25% to answer correctly. And the value that we're looking for, like how many correct answers do we want? 4. So we plug that in our calculator, guys. And then what comes out? This is approximately 0.190. So there's approximately a probability of 19% that this boy Jack is going to answer 4 answers correctly. Okay? Okay, so this is question B with the binomial. And then lastly, what is question C? B2. Find the probability that Jack answers more than 4 questions correctly. So, more than 4 questions correctly, X is the number of correctly answered questions. So we're simply going to say this, isn't it? More than. So this means more than, right? It doesn't say at least 4 or something like that. It says more than. So, this is interesting now because now we're going to look at a range. So X is the number of correctly answered questions, right? So let's have a look quickly. X could be 0, 1, 2, up until 20, right? If Jack is super, super smart and he has a lot of luck, because he's actually doing it on luck, he's just picking randomly, he may have 20 correctly answered questions, but he can also just have 0. If we say X is more than 4, that means the probability that X is 5, isn't it? Plus the probability that X is 6, plus the probability that X is 20. So we can do all of that stuff and we do the same as here. So we're going to use PDF, blah, blah, blah. But that's a lot of work. So our calculator is going to help you out here. And the calculator is going to say, hey, I can do this, but you should give me the CDF because CDF is for range. And for the CDF, we need the n, the p, and the lower bound and the upper bound. So guys, now this is important. The lower bound is what is the first value that he's gonna add, right? So this is crucial here. If we have more than 4, this actually means that p, we're looking for the probability that x is at least 5. So we start counting from 5, right? Okay, so the lower bound will be 5 here, not 4. That's important. With CDF, the calculator wants this stuff. We want to have the first one starting. We don't want this, okay? We have to translate it into this. So the lower bound will be 5. What is the upper bound? Well, that will be this one. We go up to 20. And then, what is our n and what is our p? Our n again, how many questions do we have? 20. What is our p? 1 over 4. Because every time there's a chance of 25% to answer correctly. So this is this is how we're doing. So this is actually B double I. And this is how you do that. You put this in your calculator. What comes out? 0.585. Okay. So what does this mean, guys? This means that there's a 58% chance that Jack is gonna answer more than 4 questions correctly out of the 20. Okay, so this is all binomial. Okay, so this is a binomial question. So the crucial thing here, guys, is to recognize that we're talking about binomial. For binomial, we need 2 outcomes. We need success and a failure. And the question will be said like, find the probability that Jack answers exactly 4 questions correctly. So you have to recognize that this must be like our success, right? So the event of success is that we answer a question correctly. And then exactly 4, that will be our value that we plug in. That will be this thing. But this is the crucial thing. We have to denote our x. The x is the number of successes. So that will be the number of answers, questions answered correctly. Number of questions answered correctly. Yeah, and then we are looking for the probability of success. So what is our probability to answer a question correctly? Then you have to think about, okay, what are we talking about? Every question has 3 false, 1 correct. So the probability is 1 over 4. So there are a few steps here to do. But yeah, you have to think in steps, guys. It should be fine. And then you denote your x as a binomial. You need n and p. So n is the number of trials. So in this case, we have 20 questions. P is probability of success. And then the expected value in a binomial is n times p. So that is 5 in this case. And then this stuff is using the calculator. So just be careful with PDF when we have one single value and CDF when we have a range. And then this is important. For the range, we want this, bigger or equal or smaller or equal. We don't want more than. We have to translate that into this. Okay, so there are a few things here to keep in mind. But practice with these ones and I hope this helps. Okay, bye.